about to teach you, okay, this one, examinable. Okay? Okay, so far, for the past 20 years, they have never, 25 years, they never test first principle before, never. So, my opinion is not in the syllabus. But if it comes up, but it's in our textbook, right? Never test before, but if it comes up, well, only our class before, right? And the rest of the classes, right? I told the teachers, I think it was teaching, okay, must share it. Okay, hard stuff is over. Let's do this, let's do the easy stuff now, okay? Vera, okay now, ready? Easy stuff, easy stuff. I like easy stuff. Okay, can. Okay, Sophie, ready? Video. Video? Oh, start already. Okay. Hey, the front part you cut away from me. Okay, girls. Okay, let's start with let's continue with what we have already done. For the past 45 minutes, we were working on the differentiation using first principle. But you can see, to find the expression itself, to do it algebraically, to cancel, then to find the expression itself when h equals to 0, so many steps, so long, so difficult. Can you tell me how many marks is this in the exam? What? Maximum 2. Wow, Mr. Must I do so many steps just to get an answer? Is there a faster way of doing this? Okay, everyone please watch that. Let's take a look at our answers so far, and we try to spot a pattern. We try to spot for a formula if we can, to help us to cut short all these steps and just zoom in straight and answer straight away, if it's possible. Let's take a look. For our first example, when fx equals to y equals to fx, right? Fx equals to x squared minus 3x plus 2. Our gradient function, right? Our derivative, f prime x was 2x minus 3. Sometimes instead of f prime x, we also use another symbol. We use dy dx. Meaning the derivative of, we differentiate y. This means when we differentiate y with respect to x. Okay, we use the short form WRT. Okay, with respect to x. This was our answer. Is there a shortcut way of getting this to this in half a second? There is. Okay, just wait, be patient. Look at the next one. The second example, we have y equals to fx equals to 2x squared minus 4x plus 1. After going through the first principle, expand and simplify, cancel everything, then our dy dx or our f prime x is equals to 4x minus 4. Wow, do you notice some things already? Maybe you are seeing some things, right? Okay, I will write a few more examples. You take a look and see whether you observe any pattern or not. I'm not going to do first principle now, but I'll write for you what is the answer, okay? So if it's fx, if fx is 5x squared minus 3x plus pi, f prime x is equals to 10x minus 3. Oh, Mister, how do you do that? Are you a prophet? No, I'm not a prophet. And how do I know? Alright, another one. If y equals to, I have a few. Let's say x squared. Okay. 2x cubed minus 4x squared plus 10x minus 0.5. What is my f prime x or dy dx equals to? Okay, Mr. will write down the answer. You observe a pattern, okay? 8x squared minus 8x plus 10. How do you do it, Mr.? Can I be like you? Yes. Don't be like me. Okay, 6x squared. Sorry. See the pattern? Some of you are seeing what's happening. Some of you are watching what's happening. And some of you are wondering what's happening. Need more example, right? Let me try one more. I try one more, okay? Let's say if fx equals to, I write more obvious, okay? What is f prime x equals to? Do you know already? Okay. For those who know, or if you think you know, okay, just shout out and then we all see if we can all get a pattern, okay? Okay, what is this one? Minus 10x to the power of plus 12x cubed. Wow, so many people already. Plus 21 over 2x to the power of 2 minus 4. How many wanderers do I have? Anyone still wondering where we get the formula? Anyone? No? Everyone got the formula? Everyone? Really? Explain to me how you get the formula. Rachel. Loud and clear so that everyone can hear. You hear that? Okay, I rephrase what she said. It's exactly what she said. Basically, she just said that the power, you just bring it down and multiply but to the coefficient. Notice, see, she don't say number. See, wow, we know our jargon, right? Coefficient. Power, bring it down. The index, you bring it down. The exponent, you bring it down. Multiply to the coefficient. Is that all, my dear Rachel? After what must you do? Power must subtract 1. That's it. Can we all observe that? So let me write what she just said, okay? So if E, okay, if your y is equals to ax to the power of n, whatever the expression is, so to generalize it, what Rachel is saying and say, oh, mister, I observe the pattern, power, I just bring it down. So what I have is a times n, right? Then your x stays put, then the power subtract 1. Notice the order, power, bring it down, multiply to the coefficient, then x, then power, subtract 1. Is this okay? Great. That's a lesson for today actually. See, I can actually cover in 5 minutes, 2 minutes. But to take you through the first principle, to make you experience it, then now if I show you the formula, aren't you all glad that you are not doing first principle now? Right? But when you go JC, you will need to do first principle. You have to. The teacher will write down there, find the derivative or something using first principle. Then you cannot say, answer. Cannot. You have to go through the first principle process. You need to. Alright? Okay, tell me some observation. Tell me some observation that you see. What do you notice when I differentiate constants? What happens when I differentiate constants? What do you notice? You notice over here, right? When I differentiate the number 1, but I differentiate 2x squared, right? You see the 2 comes down, 2 times 2 is 4x power subtract 1. Beautiful. Minus 4x. Hey, where did the x go? Where did the x go? If you look carefully, right? If you look carefully, this is minus 4x to the power of 1. Right? If we apply the same process like what Rachel has said, power, bring it down, multiply to the coefficient. 1 times negative 4 is negative 4. X to the power of power subtract 1. 1 minus 1 equals to what? 0. X to the power of 0 equals to what? 1. That's why it disappeared. You understand? What about the constant? Somebody, what about the constant? Where did the constant go? Over here, this is number 1. But if I want to express it in terms of x, do you agree with me this is x to the power of 0? Right? X about 0 is 1, right? So if I apply the same idea, 0, bring it down, 0 times 1 equals to 0. Then whatever happens later, I don't care already because it's 0. So it disappears. Over here, what happens when you differentiate pi? Notice pi is a number, is a constant, it does not have x inside, it's independent of x. So when you differentiate with respect to x, it's 0. Differentiate negative 0.5. Doesn't matter, becomes 0. What if we differentiate square root 3? It's a number, right? It's independent of x. Differentiate number 0. Right? So differentiate 20, 0. They will all disappear. Okay, the textbook calls this the constant rule. If you read the textbook, they call it the constant rule. So basically just saying that if you differentiate a number that does not have x, no, the whole thing got only just a number, got no x inside, you get 0. Easy, huh? Okay? Okay, you can pause the video first. Okay, so let y equals to an expression, then we differentiate. Okay, can we do it together? Just like I do right now, we do, go home, you do. What do I have? Negative 12x to the power of plus 10x. That's all. Is that okay? Simple, right? Okay, what if I give you another example? This is question 1. I give you one more. Let's say it is let y be equals to 6 over x cubed plus 7 over x squared, 7 over x plus pi. Okay, how do I differentiate this? Bring the what, sorry? Bring it up right in index form, right? Index form. So what do we have? So you notice your sec 3 stuff is very important. This is x to the power negative 3, x to the power then plus pi. Is that okay? Then you happily differentiate. So apply the same rule that Rachel talked about and what you girls have observed. Power bring down negative 18, x to the power minus 4. Minus 7, x to the power minus 2, differentiate a constant, differentiate pi is just 0. You can leave the answer like this, or if you are more skillful, you can actually write it this way. If you are more skillful, but I say if you are more skillful. If you are not very skillful, you can leave the answer here also, I can accept it. Okay, the reason why this line, I'm afraid some of you will bring the 18 down as denominator. Some of you will bring the 7 down as denominator. That is wrong. Okay? Okay? So one last one, if let's say y is equals to 2x plus 1, x minus 1 over x. Mr. want you to differentiate this. Wow, this one Mr. never teach me. How do I do it? Okay, listen if your tutors have taught you things like product rule and quotient rule, sure, good. You want to use, you can use, but I don't encourage you to do it. For now, you just stick to the technique that I've taught you. This technique, I will call this term by term differentiation. Okay, I will call this technique, what we learned today is called term by term differentiation. So if I give you a question like this, can anyone suggest to me how can I differentiate this? Now this is a whole chunk of maths, right? So what I want you to do is actually break it down into term by term, right? So what can we do? Let's expand. So 2x squared minus 2x plus x minus 1 over x. I can tidy this up. 2x squared minus x minus 1 over x. I can cancel, right? So 2x minus 1 minus 1 over x. So my y is equals to 2x minus 1 minus x to the power negative 1. I rewrite it in this form, in index form. So what just happened? When I have a complicated expression, I can tidy up to do term by term, so that it allows me to do
Please remain still wherever you are in the school.
Differentiate negative 1 is 0. Differentiate this is plus x.
Those in the classrooms, please be seated and be quiet. Those along the corridors, kindly keep still for a few moments.